All right, so now we're not doing one step. We're not doing two steps. We're doing more than that. I don't know how many. I didn't count them all up. We could count if you want on how many steps we're going to do on these problems. I would say 3 or more. So let's start with the start number 1. Okay? So write this down. You're going to see this worksheet. This is right from the worksheet. So I'm doing some of these problems for you. 4x minus 6x. This one's basically only a two-step problem. So I said it was going to be 3 or more, but this one's only 2. But you got to do something we haven't done so far.
I know what to do.
Okay, what is it?
You got like terms it.
That's it. Like terms it. Okay. I don't know if that's a verb, but that's okay. So we're going to add like terms. You always look to see if you can add like terms before you start getting rid of stuff. Everybody's paying attention, right? Okay. A lot of heads aren't looking up here. So we're going to add like terms. We've actually had a worksheet before about adding like terms, right? So now we're putting all this stuff together, right? We learned how to add like terms. You're probably wondering, why in the world do we have to do that? Well, because you're going to have equations later, right? Problems later where you're going to have to do that as part of the problem, right? It's not the only part of the problem, but it's part of it. So can't do anything to the negative 20, so I'll keep that there. Let's add these up. How do we add like terms? Just add the coefficients, okay? So how do we do that? It's a minus. What do we said this twice already today. Add the opposite, okay? So what's the rule for addition and same signs? Just add them and keep the sign. Remember that? So we add those up. What's 4 and 6? It's 10, and then we keep it negative. But what's the term? It's an x. So I just write an x. It's not an x squared. I've seen people doing that. All right? Some people think, for some reason, I don't know why, that you go x times x is x squared. This is not a multiplication problem. It's an addition problem. So you got 4 apples plus 6 apples. You got 10 apples. You with me?
Yeah.
Okay. So you just put the x right there. So that was one step. One more step and we're done. So this was only a 2-step equation. So what do we do now? What's that negative 10 doing to that x? What is it doing? What are they doing to each other? They're multiplying, right? So how do I get rid of it? Divide. Always do the opposite. The opposite of multiplication is division. So we come over here and we divide by that. All right? So x equals, what's that going to be? 2. Positive 2. That's it. Simple. Well, you probably want a challenge, don't you?
No.
Yeah, I think you do. I'm going to write an x. They put p. I'm going to write x instead of p. Is that all right? All right, let's take a look at this. Now, what's the problem with this one right there? Now, this one, I had 2 x's. It was no big deal because I just added them together and I just got just one of these x's right here, okay? But on this one, I got an x on the left side and I got an x on the right side. I would really like the x's to be where? On the same side. Doesn't matter what side they go on. It doesn't make any difference, okay? I have a preference. You prefer the left? On this particular problem, I would prefer the right. Why is that? So that you get a positive x. That's right. Now, look, we worked with a negative x here, didn't we? And we know how to deal with that. It's really not that big of a deal, to tell you the truth. But for some reason, if I was going to do this problem, I would put the x's on the right-hand side. Now, could you put the x on the left-hand side? Yeah, absolutely. Okay, but then you have to deal with a negative. Again, not that big of a deal, but it's one more thing I don't have to worry about. All right, so what I'm going to do is take this 5x, move it over here to the right-hand side. Now, how do I do that? So I look at this whole entire 5x, not just the 5, but the whole entire term. That whole entire term is being added, isn't it? It's a plus 5x. So how do I get rid of a plus 5x? I subtract it. So that's a little bit different than what we've been doing so far. Okay, I'm not just getting rid of the 5, I'm getting rid of the whole entire term. So since there's a positive, you don't see it, but if you don't see it, it's always positive, right? Since this is a positive 5x, I get rid of it by subtracting a 5x. Remember how we added like terms here? We're going to do the same thing over here. So if I subtracted a 5x from the left side, I have to what? Do it to the other side. And I'm going to subtract it from the x. I'm not going to subtract it from the 4 because they're not like terms. I subtract it from the thing that's the like term. With me? Now, when you took Algebra 1, you did these problems, and they probably canceled this out, brought everything down. But we're a little bit more advanced, hopefully, than just Algebra 1. So what I'm going to do is I'm going to take the number over here, and I'm going to put it on the other side in the same step. Right? Is that going to bother you if you do that? So look, I got the x's, so I canceled out the x's on the left side. I got the x on the right side. Now I'm going to take this 4 and put it over to the left side. So how do I get rid of that 4, that positive 4? Subtract a 4 from both sides. So I subtract it from this thing right here. Everybody see that? So basically I'm doing 2 steps into one. It just makes it, I don't know, a little cleaner, a little less writing than bringing everything down the first time. So those cancel, those cancel. Let's bring everything down. Negative 14 minus 4. We've done this several times today. It's negative 18. Equals 8x minus 5x. It's 3x. Don't forget to bring the equal sign down. For some reason, people forget to do that, and they just put 2 numbers next to each other. I don't know what we're thinking. But we got to bring the equal sign down. Now, it's really simple. Divide by 3. I don't even have to explain that. So x is negative 6. There we go. There's your multi-step equation. This was kind of 2 steps in one, wasn't it? And there was the 3rd step. And then we're good to go. Let's do another one. Let's do number 15. It's all on one page. Yeah, you only have 20 to do this time instead of, what did you have last time? 24? Yeah, they kind of squeeze them all in. Let's see, 15. All right, it's 2 times 4x minus 3 minus 8 equals 4 plus 2x. All right, so this looks a little bit more involved than what we just finished doing. Remember how we had these earlier in the other problem? We would just divide by the 2. But that's going to be a problem. I don't want to just divide this by a 2 because I have to divide everything by a 2. Now, could you do it? Yeah, you could, and it would work. But I probably would not do that. What I would do is do what our first instinct is. Remember I said that when we went over the homeworks? What's our first instinct to do with this 2? Distribute. So let's go ahead and do that. All right, so let's go ahead and distribute the 2. So what do we get? 8x minus 6 minus 8. Can I do anything on the right-hand side? No, so I'm just going to leave it like that. Now, remember on the first problem we did today, we added like terms. So look on the left side. Do we have any like terms we can add together? Yeah, the negative 6 and the minus 8. So we can add those. I can't do anything with that 8x, so I'm just going to bring it down. So I'm just going to go negative 6 minus 8, which is negative 14, equals 4 plus 2x. Now this problem looks just like the problem we finished doing. Right over there. So now I want to get the x's on the same side. Now, do you want to put the x's on the right-hand side or the left-hand side? It doesn't matter, but I think it's easier to put it on the left because how would I put it on the left? Subtract a 2x, then I'd get a positive 6x. All right. So in this particular case, I would like to put it on the left-hand side. You don't have to. You could have subtracted an 8x, but then you get a negative 6x. Do you really want to deal with a negative if you don't have to? Not really. So subtract a 2x, subtract a 2x. Put your little line right there. So you know that's going to cancel out. So instead of bringing everything down and then doing the next step, why don't we do the next step right now? So what do I have to get rid of? I already got the x's on the left-hand side. What do I want to get rid of that's next to the x? What is it? The 8? No, because I'm going to subtract those in a second. That's right. I'm going to get rid of that minus 14. Okay, that's the thing I want to get rid of. I got the x's on the left-hand side. Now I want to get rid of the regular numbers. Okay, the regular number is negative 14. So I'm going to get rid of the negative 14. How do I get rid of a minus 14? I add a 14. If I do that to the left side, I do that to the right side. See what happens to that? That cancels out. So basically I did 2 steps in one. Now we can bring everything down. 8x minus 2x is 6x. That's 0. And then 4 plus 14 is 18. All right? Then divide by 6. Divide by 6. This comes out nice and pretty. That's 3. That's it. Let's do one more because the answer is going to be weird. Let's do number 8. Kind of going backwards a little bit, but I just saw this one. I saw the answer to it. And you may look at this and say, what in the world is going on? All right, look at this one. What do you think? Well, what do you want to do? Well, there's no like terms, right? P and minus 4. You can't add like terms here. You can't add like terms here. But you can do what? Put the variable on the same side. So what side do you want to put it on? Okay, let's put it on the left. So I'm going to get rid of this P right here. How do I get rid of that? Subtract it. Now everybody's watching, right? I don't think so. I got people right in front of me not even watching.
Mr. Hammer,
I'm just saying.
I turned my head for
Right, because I'm showing something super important. And if you turn your head, you're not going to know what I'm doing. So I subtract a P, subtract a P. Now look what happens. That adds up to 0, but this adds up to 0 as well. So what's up with that? It's a P. These are P. This is a 9. That's a 9. This is a P. That's a P. That's a P. So what's going on?
It's undefined.
You can't do this problem. That's right, because what happened to the variable? It went away. It disappeared. There's no variable left. All right? So you cannot do this problem. Let's look at it and see if that makes any sense. I'm going to rewrite this. Instead of negative 9 plus P, be okay if I write it P minus 9? Now think about it. Everybody look up here. Pay attention. Lost you guys. Let's pay attention. Let's take a look at this. This represents a number. This represents the exact same number as this. Would you agree? Because it's both the letter P. All right? So if I took a number and I took 4 away from it, is there a number, if I took 4 away from it, that I'm going to get the same exact number if I also take 9 away from it? So I got a number. Pick a number in your head, all right?
8.
Take 4 away from it. What if I take 9 away from that same number? Am I going to end up with the same number? There's no way. Is there any number at all that if I take 4 away from it, I'm going to get the same thing as if I take 9 away from it? There's not. There's no number that exists. That's why there's no solution here. That's why the P's canceled out. So there's no possible value for P in this situation. So what do we write?
No solution.
You could say undefined. That'd be fine. Most of the time we usually say no solution. But you could say undefined as well. I'd be okay with that. Sometimes they do this. You ever see this? A 0 with a mark through it?
Yeah, that means undefined.
Yeah, kind of. But it's a set. It's a null set. Anybody heard of that before?
Yeah.
It's a null set. Or sometimes they write it like this. You remember back in the day when you did these set notation things? All right.
Oh, yes.
So if you put a set with nothing in it at all, stop. Guess who always gets caught? Guess who always gets caught? The one that retaliates. They always. All right. You play football, right? Don't you understand that? Okay, so stop. So let's take a look. So this is. Can I just make a side remark and you just listen, and then we can go on? It'd be really nice. That's the way it's supposed to work. So look, this is called the null set. Sometimes they call this the null set or the empty set. Does anybody learn that back in the day when they were kids? Either elementary school, middle school, Algebra 1, they probably did this. I don't know. But anyway, there it is. Who cares? Just write no solution. All right, for that. All right, I think that's pretty much what this worksheet's all about. All right. My goodness, I've done how many for you?
5.
I've done 1/5 of your homework for you. How's that?
Oh, thank
All right.
you.
All right, so let me pass it out, and you can work on that.